Hi everyone. So today we're going to be going through finding the circumference of a circle. For those of you who don't know me, yet maybe this is your first time. I'm Evelyn. I study at the University of Birmingham, and I'm studying for my master's in maths. So let's get started with the session. So before we start with finding a circumference of a circle, we're just going to do a quick recap on what we did on Monday. So we looked at the formula for the area of a circle, which is A equals pi r squared. We also looked at how to find the area of a semicircle. So to do that, you need to find the area of the whole circle and then divide it by 2. To find the area of a quarter circle, you just need to find the area of the whole circle again and then divide it by 4. And then if you want to find the area of a sector, use this particular formula. So you take the angle in the sector, you divide it by 360, and then you multiply it by your area of a whole circle, which is pi r squared. And then finally, we also looked at the area of compound shapes. So to find the area of compound shapes, you should split your compound shape into simple shapes, like say squares or rectangles, things which are easier for you to calculate the area of, and then calculate the areas of each of those smaller shapes and then add them all together to get the area of a compound shape. One thing to remember, which I did sort of point out on Monday as well, is make sure when you are writing the area of a circle or any shape, you always make sure you have your units, and it should be the units they give you squared. So let's say centimeters squared or meters squared, things like that. So let's have a look at this question here. It sort of puts together both of the things that we went through on Monday. So I should say on the left, there is a semicircle in a rectangle. The rectangle has dimensions 16 centimeters by 8 centimeters. So calculate the area of the unshaded section and give your answer to 3 significant figures. So what we're going to do here is we are going to draw on our shape all the dimensions that they've given us. So they said it's 16 centimeters by 8 centimeters. So this one's a longer side, so I'm going to call this one 16 centimeters. I'm going to call this one 8 centimeters here. So we can treat this as a similar to a compound shape sort of question. We could work out the area of the rectangle and then take away the area of the semicircle. Now for this one, you are going to need a calculator. I'm going to get mine. Just so we can work out an accurate answer and give it to 3 significant figures. So let's work out the area of the rectangle first. So the rectangle, remember, area of a rectangle is just base times height. So that's going to be 16 times 8. So your area of a rectangle is 128 centimeters squared. And then now we want to find the area of the semicircle. So let me zoom out as well a little bit. So I'll write it down here. So semicircle. So remember, to find the area of a semicircle, we need to find the area of the whole circle and then half it. So if we know that this whole line down here, which is our base of our rectangle, is 16 centimeters, and we know that this is a semicircle, this means that this is also our diameter for the circle as well. Yeah, so we can use this value 16 as our diameter, which means that our radius, remember our radius is half of our diameter. So to get to our radius, we need to do 16 divided by 2. 16 divided by 2 is 8 centimeters. And then we can use this value for our radius to work out the area of the whole circle and then the semicircle. So we know the area of the whole circle is pi r squared. So we've got pi multiplied by r, which was our radius, squared. So we should multiply it by 8 squared. So when we use our calculators, pi times 8 squared equals 201.0619, and then it goes on a little bit. And then remember, we want to find the area of the semicircle. So we need to now half this. So what I was saying on Monday is use your answer button on your calculator. So the one that says A and S. So all you need to do is click it or press it and then divide it by 2. And what you should get now for your area of semicircle is 100.53, and it goes on. And remember, it's still area, so it's still centimeters squared. Now, we still haven't finished the question yet because we still need to work out the area of the unshaded section. So now we still need to do the area of the rectangle minus the area of the semicircle. So our final part, which I'll do in a different color, I'll do it down here. We want to do the rectangle and take away the semicircle. So that would be 128 centimeters squared, take away 100.53 centimeters squared. So when you calculate this, remember, try and keep all your numbers in the calculator if you can, just to try and make it as accurate as possible. And you should get 27.47, yeah, centimeters squared. Remember, it's still an area. Now, we're still not done yet because we need to leave it in 3 significant figures. So our final answer, which I'll do in orange, should be 27.5 centimeters squared. So hopefully, if I zoom out a little bit so you can see the whole question, hopefully that sort of sums up everything that we did on Monday. Does anyone have any questions? No. Perfect. Cool. So well done, guys. I hope that all sort of sums up everything that we did on Monday. Now we're going to move on to finding the circumference of a circle. So this is going to be today's session. Today we're going to be learning how to calculate the circumference of a circle. So we're going to look at a new formula today, how to calculate the arc length. So remember what the arc is on a circle. It's like part of your circumference. And also we're going to go through how to find the area of triangles, trapeziums, and parallelograms as well. So let's start off with the circumference of a circle. So there are two formulae that you could use for the circumference of a circle. So the two that you could use is C equals 2 pi r or C equals pi d. Now remember, the radius is half the diameter. So both of these equations or formula are exactly the same. Because remember, 2 times the radius equals the diameter. So really, 2 pi r is the same as pi d. So depending on what they give you, whether they give you the radius or the diameter, that will tell you which one you would need to use. It's okay just to remember one of them, because once you understand how to get the diameter when you have the radius or vice versa, you'll be able to figure it out either way. So if we look at a quick example question, so shown below, you have a circle with radius 10 centimeters. We need to work out the circumference of the circle and give your answers in terms of pi. So first things first, our equation the equation that I'm going to use is going to be C equals 2 pi r because they've given us the radius. So all we need to do now is do 2 times pi times 10, which is our radius. Now remember, they've asked us to leave our answer in terms of pi. So we sort of brushed on that on Monday as well. So if they do ask us to leave it in terms of pi, we don't actually need to use a calculator. all we need to do is do 2 times 10, so we get 20, and then we're still multiplying by pi, so we just leave pi on the end like that. So we've got 20 pi. So our answer would just be 20 pi centimeters. So that's how we work out the circumference of a whole circle. Now, arc length. I know some of you were asking, what is the arc length? So if I draw a quick example. Now remember last time on Monday, we were going through area. If you weren't there, don't worry, I'll quickly go through it as well. So this is a sector. It's like a slice of pizza or a slice of cake, and you're given your angle in the middle here. So you're given what this angle is. Now your arc length is this length here. It's like a part of your circumference. So that's, remember, this part of the circle is called the arc. So it looks like an arch basically. So that's the length that we want to try and figure out. Now, the way how we're going to try and figure out the arc length is exactly the way how we tried to work out the area of the sector, only using our circumference instead of our area of the circle. So we take the angle from the sector and we divide it by 360, and then we multiply it with the circumference of the entire circle. So we are going to go through a quick example question for this as well, and hopefully it should make a bit more sense when we go through this question. So we've got a sector here, looks like a slice of pizza, and we've got this angle 60 degrees, and we've got our radius, which is 12 centimeters. Now remember, your radius is just a line that goes from the center of the circle to the edge of the circle. So that's our radius, 12 centimeters. Now they want us to calculate the length of the arc. So they want us to calculate this length here, this curved part here. So it's just a part of our circumference. So to do this, we need to take the angle that they've given us, the angle of the sector, so 60 degrees, and we're going to divide it by 360 degrees. So that's the total angle around a point. That's the reason why we're using 360 instead of any other angle. And then we're going to multiply it by the circumference of the entire circle. Now remember, circumference equals 2 pi r. So all we want to multiply it with is multiply it with 2 and multiply it with pi and multiply it with our radius, which is 12. And then once you calculate it, so if we do that as well, so 60 divided by 360, multiplied by 2, multiplied by pi, and multiply it by 12. The best way to do this is just to put it all into the calculator, then you'll get an accurate answer. And you should get something like this. So 12.56637, and then it goes on a little bit. Now, remember what I was saying as well. If you do get a long decimal number and they don't tell you how to leave your answer to at least one decimal place. So I'm going to leave mine to 12.6 because 6 is a number after 5, so we need to round up. So it'd be 12.6 centimeters. So does anyone have any questions? Yes, the arc, so someone's asked, is the arc always curved? Yes, it is always curved. The reason why is because your circumference is always curved. So all we're doing is like sort of taking a little bit of my circumference and I just want to work out how long that is. So it will always be curved. It's never a straight line. And someone else asked, why is the arc length important? Is it because it helps figure out the circumference? So if I go back quickly, and actually I will do a little demonstration as well. So, and the arc length is important. The reason why I say it is because you could be asked a question to work out the perimeter of a shape. So let's say you had a shape where you've got a square or a rectangle, and they've given you like a quarter circle. something like this, and they've asked you, and they've given you the different measurements for your rectangle, and they've given you the radius for your quarter circle. They might ask you to work out the perimeter. I do have some questions similar to this, which we are going to go through during the lesson, but just as a quick demonstration, you need to be able to work out the area of this sector. So easily enough, this is just the quarter circle. So we could treat it as if we were working out the area. We work out the whole circumference of the whole circle and then divide it by 4 just to get that little part. So the length of the arc is important to know how to do it, because they do expect you to know it for your exam. The only thing is, it doesn't help you work out the circumference. You need the circumference to work out the sector, the arc length. So hopefully that answers your question. Yes, we will do Kahoot today a little bit later. Cool. So let's continue from here. So we finished this question. Hopefully working out the length of an arc makes a little bit more sense. We will go through a few more examples throughout the lesson to make sure everyone understands it. So as I was just saying as well, you might be given a semicircle or a quarter circle. These ones are the easiest arc lengths to work out, because you don't need to use the angle. You just need to sort of think about how big or what proportion do these have in comparison to the entire circle. So here we have a semicircle, if I draw one quickly. So we know a semicircle is half of a circle. So if we wanted to work out just this arc here, to do this, what we would need to do is work out the circumference of the entire circle and then divide it by 2, and that gives us just this arc here. The quarter circle, sort of like what I drew a few minutes ago, looks like this. So we know that a quarter circle is literally quarter of a circle. So to work out this arc, so this curved line here, all we need to do is we need to find the circumference of the whole circle and then divide it by 4. And that's how we work out just this length. Now, let's have a look at this question here. This is sort of a typical question that they might ask you, and this is a past paper question as well. So hopefully this sums it up a little bit better. So we have a circle and it has a radius of 5.6 centimeters. Work out the circumference of the circle. So remember, the formula for circumference of a circle is C equals 2 pi r. So all we want to do here, do 2 multiplied by pi and then multiplied by our radius, which is 5.6. So if we use a calculator, 2 times pi times 5.6, we get 35.1858, and it goes on a little bit. Now remember, they haven't told us how to leave it, so leave it to at least 1 decimal place. So I would say that that is 35.2. So that would be our answer for the first one. Now, because they haven't told you how to leave your answer, in the mark scheme, they do give you leeway. So if you left it to 2 decimal places or 1 decimal place or 2 significant figures, you would still get the mark for that question. Just don't leave it to 1 significant figure. That's one that they won't take. So don't leave it something like 40, something like that. So the next question is, a semicircle has radius 5.6 centimeters. Work out the perimeter of the semicircle. Now, everything that we've gone through so far has all been about the arc length. It hasn't been about the perimeter. Now remember, perimeter is the distance that you walk all around the shape, not just a part of the shape. So we need to work out this length here and then add it to this entire length here as well. That's how we're going to work out the perimeter. So we can work out the arc length first. We can work out this part, because this is just a semicircle for this circle here. They have exactly the same radius. yeah, 5.6 centimeters. So this is just half of this one over here. So all we're going to do is we're going to half the circumference of the circle that we just worked out to work out what this length is going to be here. So let's do that quickly. So we got 35.1858. Hopefully this is still stored in your calculator, so you can still press your answer button on your calculator and divide it by 2. So that length there will be 17.5929. Now, if it's not stored in your calculator, just quickly do 2 times pi times 5.6, because remember, we still want to make it as accurate as possible. We don't want to round too early. If you round too early, you will get the wrong answer in the end. So if we do 2 times pi times r again to get 35.1858, and then we divide that by 2, you get 17.5929, and it goes on a little bit. And then the last thing that we want to do is work out how long this section is. Now remember, this section is just our diameter because it will be 2 radii. So it will be this radius, which is 5.6, plus this radius over here, which is also 5.6. So you can either add 5.6 twice, or you can multiply 5.6 by 2 and add it. So 5.6 multiplied by 2 is 11.2. And then all we want to do is add these two together. So what you should get is 28.7929, and it goes on, and that will be your perimeter of the semicircle. So leave it to 1 or at least 1 decimal place. So you've got 28.8 centimeters, and that would be your answer for the perimeter of a semicircle. So hopefully this makes a little bit more sense. No problem. So some people have asked to just explain how to work out the perimeter again. That's no problem. So the perimeter, remember, is how long it takes, or the length that you walk all around the shape. Yeah. So if I started at this point over here, I'd have to walk all along this arc, and then all along this line back to the same point that I started. So that's the length all around the shape. So since I know that this line, which goes from one end of the circle to the other end, and it goes through the middle, I know that this is my diameter. And I also know that my diameter is 2 radius put together. So I know that it will be by 5.6 here and another 5.6 here, because radius always has the same length, yeah? So it doesn't matter which line it is, it always has the same value. So I know that I'm going to have to add 2 5.6s on the end, and then I also have to add on whatever this length of my arc was. Now remember, we just calculated the circumference, so all I would have to do is half it, because this is a semicircle. Now some of you were asking about the quarter circle. It works in a very similar way. If I just want to work out the arc here, then I would just divide it by 4. If I want the perimeter, I have to add the radius as well. Yeah. So let's say that my radius was 2. I'd have to add 4 onto whatever I got my arc length to be. Hopefully that makes a bit more sense. I might be able to go through another example question with you a little bit later, so that everyone understands it. So let's go on to the next part. So the next part of this session today is going to be going through areas of triangles, trapeziums, and parallelograms. So the area for triangle is half your base times your height. Remember to use the actual height of a triangle and not the slant height. They do give you the slant height to sort of throw you off. You don't actually need that part to work out the area of a triangle. You only need the vertical height of the triangle. So if we look at this example down here, we've got area equals half times, now the base of this triangle is 10 centimeters because it goes all along the bottom of the triangle. So that will be our base, and our height would be our vertical height. What's the entire height of the actual triangle, not the slant height? So we're going to use 5 centimeters. That's our vertical height. The slant height is 8 centimeters. That doesn't help us with working out the area. So we're going to do a half times 10 times 5. So a half times 10 times 5 is 25. And remember your units. Your units here is centimeters, and we're working out the area, so it's going to be centimeters squared. Hopefully that makes some sense as well. We are going to move on to trapeziums. So let's have a quick look at trapeziums as well. So the area of a trapezium is half times your A plus B in brackets multiplied by your height. Yeah, so remember with bid maths, B comes first, so it's brackets. You always work out the brackets first. Do the A plus B, and then you can multiply all of the three together. Now A and B, always remember that they are the parallel lines in a trapezium. They're not the slanted ones, they're not ones which are touching together, they're always the ones which never touch, the parallel lines. And your H is your height of the trapezium. So that's sort of like the distance between those two lines that you're calculating. So if we look at this example, calculate the area of the trapezium. So we've got our two parallel lines. Now, in your exam and in questions, they do tell you which ones are the parallel lines with these little arrows. So as long as your lines have those arrows on them, it tells you that's your A and your B. It doesn't matter which one you choose to be A and B. All we know is that we're going to add these two together. So so our area is going to be a half multiplied by our bracket, 14 plus 11. And then we're going to multiply our height. Now our height is 10 because that's how tall the trapezium is. So we're going to multiply it by 10. So we've got a half times 14 plus 11 times 10. Now bid maths, we need to do the brackets first. So we're going to do 14 plus 11. So we get 25. So we've got a half times 25 times 10. So our answer is going to be 125. Remember it's area, so we need our units. Now they gave us centimeters, so our area is going to be centimeters squared. Cool. And then the last area that we're going to go through is a parallelogram. Now the area for parallelogram is base times height. It's sort of like a rectangle, yeah? So remember, do not use the slant height, use the actual height of the parallelogram. So they will give you the slant height to throw you off, just like with triangles. Try and make sure that you do not fall for it. So here, my base is 12 centimeters because that's the length of the base of my parallelogram. So I'm going to do 12 multiplied by my actual vertical height, which is 4 centimeters. It's got 12 times 4 centimeters, which is going to be 48. Now it's area, so we use our units, centimeters squared. So hopefully that makes a lot of sense. Before I answer some more questions, just going to go through some an example question here and common mistakes, and then I will check out the rest of the questions. So this diagram here shows a parallelogram. Now they've told us our base has a length y and our vertical height has this length 6 centimeters. Now they've given us the area. So sometimes in exam questions, they might give you the area and they might want you to work backwards to work out what one of the lengths are. Yeah, they ask it quite a lot with rectangles and squares and triangles. Parallelograms are very similar as well. So the area of the parallelogram is 54 centimeters squared. Find the length of the base y. Now, first of all, we should remember our equation or our formula for the area of a parallelogram. It's just base times height. So we know that our area, which is 54, this equals to our base multiplied by our height, which is 6. So that will be 6 times y. So this is 6y. So now we just have an algebraic equation, which we're just going to rearrange to solve for y. So in order to do this, we need to divide by 6 on both sides of the equation. So we're going to do 54 divided by 6, and 6y divided by 6 just gives me y. So we know that y is equal to 54 divided by 6, and 54 divided by 6 is 9. So y equals 9 centimeters. Now, if you wanted to work in the opposite direction just to check it, 9 times 6 is 54. So y must be 9. So hopefully that sort of sums up the different areas that you could have for more difficult 2D shapes. Let me quickly just go through some common mistakes that students make, because maybe this might answer some of the questions that have been asked so far. So remember, always remember, your radius is half of your diameter. A lot of students forget this and they use the diameter instead of the radius, or the radius instead of the diameter when working out the circumference or even the area. Always remember which one you need to use. A lot of students forget to use the right units. Be careful with the question. Make sure you read the question properly as well, because it will tell you how to leave your answer, and it would just be a silly mistake not to leave your answer correctly after you've done so much working out. You've gotten the correct answer, but you've written it down in a way that they didn't want. Also remember, do not round too early. Rounding too early will give you wrong answers. They won't be as accurate, and you will lose marks for it as well. And remember, don't use the slant height. Only use the actual vertical height of the shape, not the slant height. They will put it in there to throw you off, so really be careful with those. So we are going to do a Kahoot quiz today as well, but before we get onto the quiz, I know there's quite a few questions which people have asked, so I'm just going to go through that first, and then we will go through the Kahoot quiz at the end. Okay, so someone's asked, why is it squared? I'm guessing you're talking about the centimeters squared at the end. So area, if I go back quickly, area is always centimeters squared or meters squared or whatnot, because if you think about it, you're timesing a length by a length. So really you're doing centimeters times centimeters, aren't you? That's why we have centimeters squared, or meters times meters, which would give you meters squared. Whereas when you're doing like say a length, like a perimeter, you're just adding them together, you're not multiplying them. So you're just left with your centimeters or your meters. That won't be squared. Now, one thing also to point out is when you are working out volume, you're multiplying 3 lengths together, aren't you? So you're doing centimeters times centimeters times centimeters. So volume will be cubed because you're timesing it by 3. You're timesing it 3 times. Yeah, so always sort of, that might help you to remember how to leave your units. Length is always just a normal unit, centimeters or meters. Area is squared and volume is cubed. Hopefully that makes a bit of sense as well. You guys are really wanting jokes. I don't have any maths jokes. I think you'll find mine really corny. I'm glad that makes a lot of sense. Right, the slant height. So the slant height is this one here. This isn't your actual height. That's not the height of your shape. Now we want the actual vertical height. We want to see how tall it is. So we always have to use the one that's going vertically between your 2 parallel lines. Yeah, same thing with your triangle as well. You always want your vertical height, not your slant height. Because if I did 8 times 10, that would give me 80, and that would be much larger than the actual area of the triangle. So that's why we always use the vertical height and not the slant height, because it won't ever give us the correct answer. So make sure you do use the accurate, the actual height. They do it to trick you. They put the slant height there to trick you, to see whether you're paying attention and reading the question properly. They do it deliberately. That's why you need to make sure that you are paying attention to the question and reading it properly and making sure you use the actual height, because they will do those sort of things to see whether you're paying attention to your working out or not. So make sure you are paying attention. Okay, so I'm sorry if some of you might not understand a lot of the stuff that I've gone through today, but we will go through some more questions and hopefully it will make a little bit more sense. You can rewatch it as well on the YouTube, on the My Tutor YouTube channel. And yeah, let's maybe the Kahoot quiz will help as well. So here is the PIN number and the website. So please join, feel comfortable joining, and hopefully this will help some of your understanding. If some of your devices aren't working where you can't sign into Kahoot, please still play along. Hopefully you'll enjoy it just as much, even not being part of the quiz actively, but hopefully it will all make a little bit more sense after these questions. So I'll wait a little bit for some of you to sign up and log in, and then we can start. Right, I'll wait a little bit more just in case there are still some more people who want to log in, and then I will start. Right, perfect. I'm gonna press start now, guys. I think you can still join in halfway through. The game pin will still be at the bottom of the screen. So there's 10 questions and I'd like everyone to give it their best shot. So what is the area of this shape? So remember, this is a parallelogram. How do we work out the area of a parallelogram? Perfect. So yeah, it is 24 centimeters squared, because remember the area of a parallelogram is just base times height. So it'd just be 3 times 8. So let's go on to the next question. So well done, guys, and well done to everyone in the top 5. So let's go to the next question. True or false? The area of a trapezium is half times a plus b times height. Perfect. So yeah, it is. It is always half times your parallel line, so your A plus your B, multiplied by your height. Well done, everyone. Cool. So the top 5 is shifting a little bit. So which equation is the correct formula for the circumference of a circle? So which one is it? Which one could we use? make sure you read each of the equations properly as well. So some of these ones might have tricked some of you. So remember, you can have two formulae for your circumference of a circle. Is either C equals 2 pi r or C equals pi times d, because remember your radius is half of your diameter. So some of you might have clicked 2 pi d. Remember that it's 2 pi r. Some of you might have picked pi r squared. Remember that's your area of a circle, not your circumference of a circle. And 2 pi r squared is not a formula that you use to work out anything for circles. Okay, so let's have a look at the leaderboard then. So well done, guys. Let's continue. So we've got a quiz, another quiz question. So the area of a triangle is 21 centimeters squared. What is the base of the triangle? So what is the value of y? Now remember your area for a triangle and then try and work backwards. What would your y have to be to give you an area of 21 centimeters squared? Perfect. So remember, area of a triangle is half times base times height. So we need to do a half multiplied by our y multiplied by 6. So if our base was 7, we do a half multiplied by 7 times 6, and you would get 21 when you do that calculation. Cool. So let's look at the leaderboard then. So it's slightly shifting again. Cool. So let's have another look at another question. What is the circumference of the mirror in terms of pi? So we have a circular mirror. The diameter is 1.3 meters. How do we work out the circumference? Remember the difference between the diameter and the radius. Perfect. So yeah, remember two equations that you could have for your circumference of a circle. You could have pi times d or 2 pi r. Now here they gave us our diameter, so we just need to do our diameter multiplied by pi. So it'd be 1.3 pi. Perfect. So still shifting a little bit more. So the perimeter of this semicircle is 30.8 millimeters. Is the perimeter of this circle 30.8 millimeters? Be careful of the difference between the perimeter and just the length of the arc. Make sure you are calculating the perimeter. Right, guys, remember you're calculating the perimeter. You need to work out the length of the arc. So you work out the circumference of the entire circle. You divide it by 2 to work out the length of the arc, and then you have to add 12 back on to the end of it. So you should do 12 times pi divided by 2 to work out the length of the arc, and then add 12 and you will get 30.8. Okay, so really be careful with perimeter as well. So what is the area of this particular shape? Now this is a trapezium. I've given you guys a minute, so don't rush it. Remember, what is the formula for the area of a trapezium? Make sure that you use bid mass as well with this particular formula, and try to figure out which is the correct answer. Okay, cool. Well done, guys. So it is a half times a plus b multiplied by the height. So you need to do a plus b, which was 8 plus 2, so you get 10, multiply it by a half, and then multiply it by 6. So you would get 30 centimeters squared. Cool. So Winnie is now top of the leaderboard. Well done, guys, to everyone participating. So we've got about 3 more questions left. So what is the length? So the length of the arc is 12.6 millimeters. So this is now just the length of the curved section. It's just the length of the arc. Now I will say, be careful with one particular part of this question. Be very vigilant. Well done for those of you who realize that. If I quickly show you what it was again. So here they've given us our arc, our sector. We can work out the arc length. However, it's in centimeters. Now the answer they gave us was in millimeters. So of course it was not going to be correct. Remember to be very, very vigilant with your units. Okay, right. Cool. So the leaderboard is still shifting a little bit. It could be anyone's game, to be fair. So what shape has the area 24 centimeters squared? I've given you guys a minute to work out which one would have this particular property. So remember your areas for your different shapes. Which one would be 24 centimeters squared? All right then, perfect. Well done, guys. So yeah, it is the triangle. Remember, triangle has the area half times base times height. So we need to do 12 times 4 and then half it. So 12 times 4 is 48. Half it is 24. Perfect. And the other one, so parallelogram, remember the area of a parallelogram is base times height. The area of a rectangle is also base times height. And the area of a trapezium is half multiplied by a plus b multiplied by height. So the leaderboard is still changing. I think we've got this last question and it is worth double the points. So what is the area of the shaded section? So I've given you a minute and a half to work this out. So don't rush it. How would we work out the area of the shaded section? We've got a large triangle and a smaller rectangle in the middle. How do you think we could work out the area of the shaded section? So remember your area for a triangle, remember your area for a rectangle, and then what would you do once you've worked out those? So 10 seconds left, guys, for anyone else who wants to put in an answer for this question. Okay, let's have a look. Perfect, well done guys. So yeah, we need to work out the area of a triangle, half times base times height. Then we would work out the area of a rectangle, and then we work out the difference between them. We take the area of a rectangle away from the area of the larger triangle. So that is the end of the questions. Let's see who came first, second, and third. So third is Lilac. Second is the black heart emoji. And first is Winnie. Well done, guys. And well done to the runners up as well, Bot and Jeff. Perfect. So hopefully that sort of clears up some of the questions anyone has. If anyone still does have some more questions, please put them in the Q&A section now, and I will try to answer them. If there aren't any questions, I will be looking at the Q&A section until the end of the lesson. But for now, what we will do is we will have a look at some past paper questions as well. So perfect. Cool. So let's have a look at this question then. So we've got a quarter circle, and they want us to calculate the perimeter of a quarter circle with radius 7 centimeters. So remember, this is the perimeter, not the length of the arc. So not only do we have to work out this arced shape, but we also have to add on the other two straight lines on our quarter circle as well. So first of all, let's try and work out the area of the arc. So we need to work out the area, not the area of the arc, the length of the arc. We need to work out the circumference of the entire circle and then divide it by 4, because this is a quarter of the circle. So remember, circumference is pi 2 pi r. So the circumference of the entire circle is going to be 2 multiplied by pi multiplied by our radius, which is 7. So if we use our calculator, 2 times pi times 7, we've got 43.98 and then it keeps going. Store this in your calculator and divide it by 4, so we can get our length of just this quarter circle, because we have to divide it by 4. So when we press A and S on the computer, on the calculator, and we divide it by 4, we get 10, I'll write it down here actually, 10.995 and it goes on a little bit. So that is just the length of, and if I zoom out and I show you, so what we've just calculated here, we've worked out the circumference of the whole circle and divided it by 4. That's this length over here. That's what we've calculated. Now we need to calculate, now we need to add the lengths of the two straight lines to work out the entire perimeter of the shape. So we need to add this section here, and we need to add this section here. Now remember, these two are radii, because they're two lines which go from the center of the circle to the edge. So not only does this length here have a length of 7 centimeters, this one here also has a length of 7 centimeters, because it is also still the radius. So our final step now is to do our 10.9955. Make sure that it's still stored in the calculator. Press A and S, and then you're going to add 7 and add 7 again. So add 7 and add 7 again, and you should get 24.9955, and it goes on. Now, I would say leave it to at least 1 decimal place. If we round this, we are just going to get to 25 centimeters. So hopefully that makes a lot more sense to everyone. I'm going to look at the Q&A section now to answer any questions that might have come up. So some people, so I'm glad some people are really understanding it, and they're happy with what they learned today. I'm really glad. The next lesson that I'm doing is next week, Monday. In the exam, would they ask you to work out less than a quarter of a circle? Yes. They could ask you to work out less than a quarter circle. They might ask you, that's why we need to work out the length or perimeter of a sector. So what we were going through before, if I show you quickly, here we go. So when we were doing this one, this would be less, it would be smaller than a quarter circle. This is how you would calculate it. So this is what I was trying to explain earlier, how to find the arc length. So if you're given any sort of slice of pizza or any sort of like part of a circle, which is represented by a sector, to work out this part over here, this light blue part, which I've just drawn, you would use this formula, which is similar to how we work out the area of the sector, which I did on Monday. You take the angle inside of the sector, you divide it by 360, and you multiply it by the entire circumference of the circle. So hopefully that sort of clears up sectors. Monday's lesson, I have to get back to you on that one. But I think we've got some more time for maybe one more question. And we might as well go through this one, since it's one thing which everyone is sort of asking questions about. So hopefully after this, it does make a little bit more sense. So we want to calculate the perimeter of the sector. So what we're going to do is we are going to first of all work out the length of the arc. So we're going to work out this part here, and then we're going to add it to the two straight lines. Now remember, our two straight lines are our radii. They're lines which go from the center of the circle to the edge. So first of all, let's work out the length of the arc. Now remember, to do this, we need to take the angle, we're going to divide it by 360, and then we're going to multiply it with our circumference of the entire circle, which is 2 times pi times r. So all we want to do now is actually just put these numbers into our formula. So the angle that they've given us is 82, and we're going to divide it by 360, and then we're going to multiply it by 2, multiply it by pi, and then multiply it by our radius. Now radius is 6 centimeters. So we're going to multiply it by 6. So if we put this all into the calculator, 82 over 360 multiplied by 2, multiplied by pi, and multiply it by 6, you should get 8.587, and it goes on a little bit. And make sure you store this into your calculator, because we don't want to round too early. We do want an accurate answer at the end. So press your A and S button, and then the final thing that we want to do is we want to add on our 6 centimeters, which is this line here, and we want to add on our other 6 centimeters, because remember, these are both radius. These both give us a radius. These are both exactly the same value. So we're just going to press A and S, and then we're going to add 6 and add 6 again to get the entire perimeter. And when we do this, you should get 20. So if I write this down here as well. So we want to do 8.587. So whatever you got in your calculator, plus 6 gives you 20.587, and it goes on a little bit as well. So let me zoom out as well. So the final thing to do is to leave your answer as they've told you to. Give it as 2 decimal places. So 20.587 to 2 decimal places is 20.59. And remember your units. So this is just length, because it's perimeter. We were just adding all of our lengths together. So our perimeter would be 20.59 centimeters. So hopefully that makes a lot more sense to everyone. And there will be, on Monday, I will do another Kahoot session, since everyone seems to love doing the Kahoots. I hope that I hope that this did make a bit more sense. We will do a recap next week, Monday. But thank you guys for participating in today's session.
Brilliant. Thank you so much for the session today, Evelyn, and everyone for attending. We've got physics this afternoon and higher maths as well. But if not, then see you in our next foundation maths session, and have a lovely rest of your week, everyone. Bye.
Bye.